All right, here we go. So now we're going to talk about increasing and decreasing intervals. So whenever you're looking at a graph, you always make sure you're reading it left to right. So if we start on this graph is actually at the start. It's not doing either. It's not increasing, it's not decreasing. This is constant. Then from here to here is where we see we're going down, like you're going down the hill. So this is decreasing. Here, we're going back up the hill. So right here is where we have our increasing. And then it finishes. And we're going to pretend like we have an arrow on this side and an arrow on this side. And so this part is our decreasing. All right. So if we wanted to start with our increasing interval, you're only looking at x values. So our x, where it starts, is at 0. From 0 to when it hits 6, it's increasing, okay? You're going to use parentheses when you do this because when you're considering increasing and decreasing, at the point 0 and at the point 6, it's not increasing anymore because it's stopping to change direction. So that's not included because it's stopped at that point. If we were going to look at our constant, so our constant interval where we're not increasing or decreasing, again, I said we're going to pretend like there's this arrow on this side. So this is continuing on, and we're just going to assume that it keeps the same behavior. So we would say from negative infinity, because it's going to the left forever, until we hit -5 is our constant interval. And then our decreasing intervals, as you can see, we have two pieces of our decreasing. So we're always going to start, again, left to right. So starting at the left, it starts decreasing at -5 until it hits 0. So we're going to do -5 to 0. Then anytime you have a gap of information, but you want to show that those two pieces are connected, we're going to do a union, and then we're going to pick back up. So that union means, hey, I'm going to stop for a second, but I want you to keep these two intervals connected. So starting at 6 all the way to, does not matter that it's going down. Remember, we're just thinking about x values, okay? So this is going to the right slowly, so until infinity, it's going to be decreasing. So that would be our increasing, decreasing, and constant, all right? Really making sure, really common things that we mess up on are those negative infinity, positive infinity things, and really making sure that you guys are only using x values. So we're not looking at the y values when we do this, just x values. Okay, next one is if you're given an equation. So like I said, when you are given an equation, graph that equation, sketch it, get an idea of what you're looking at. All right, so if we were to sketch what we were looking at, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. All right, so if we were to sketch what we were looking at, +4 is telling us left 4, -5 is telling us down 5. So left 4, down 5, nothing else is happening, so we're following this x squared shape, which again, remember, is that parabola. So we look something like that. Doesn't have to be perfect, you're just getting an idea of what you're talking about. All right, so if we think left to right, starting at the left part of this graph, even though this arrow is going up, that does not matter because as we're coming from the left, we're going down, down, down. So we're decreasing, decreasing, decreasing until we hit our vertex, and then once we hit our vertex, we're increasing, increasing, increasing. So our decreasing interval, again, just thinking about x values, is negative infinity because it's going to the left, all right? So everything from the left, like if we were to start up here, we're coming from the left, which is negative infinity, all the way until we hit that -4. Again, none of this is included, all right? We're using parentheses when we talk increasing, decreasing. And then our increasing interval is from that same vertex, so -4, and then to the right, it's going forever and ever, it's going up, so positive infinity. So that would be our increasing, decreasing. They loved this question on your guys' homework. So I don't know. Like I said, I don't know what's coming on it, but I would maybe be ready for that. Okay, next thing is talking about parallel and perpendicular. So remember, if they are parallel, they have the same slope. If they are perpendicular, it is opposite, so positive, negative, opposite, and it's the reciprocal, so opposite, reciprocal. So a line that is perpendicular to y plus 1 equals 1/2 x minus 4. This is your point slope form, remember? So this is y minus y1 is equal to m x minus x1. M is our slope, so this is the slope that we're talking about, and it goes through the point -2, 5. So if we're perpendicular, opposite reciprocal of 1/2 would be -2. Okay, so that's going to be our slope. And then we are going to plug in this point, all right? And when we plug in a point, this is going to be our x1, y1. So we're going to use this slope and we're going to plug it in. And we're going to say y minus 5 is equal to our m value, -2. X minus -2 is going to be plus 2. Now, technically, that's the equation for a line, so if you wanted to stop there, you could. If you wanted to go one step further and do slope-intercept form, we would distribute this -2, and we'd have y minus 5 is equal to -2x minus 4. Then we would add this 5, and we would get y equals -2x plus 1. So that would be a perpendicular line that goes through that point. Parallel line, all right, same slope. This is written in standard form right now. So right now we don't have an m value, so we need to solve for that. Easiest way to solve for that is we're just going to solve for y. So if I was going to solve for y, I would start by subtracting this 3x on both sides. This cancels, and I'm going to have 2y is equal to -3x plus 5. Then I'm dividing by 2. When I divide by 2, I'm dividing this whole side. That's a mistake that some of us keep making, okay? So this would be y equals -3 over 2x plus 5 over 2. So our m value is right here, okay? Parallel has the same slope, so now we're going to use this point, x1, y1, and we're going to say y minus -4 is y plus 4 is equal to -3/2 x minus 1. Again, that's technically the equation of a line, so you could stop there, or we can distribute, and we're going to get y plus 4 is equal to -3/2 x plus 3/2, because negative times a negative is a positive. 1 times 3/2 is still 3/2. And then we are going to subtract 4. When you go to subtract 4, the only way that you can subtract 4 is if they have the same denominator. So you're going to rewrite 4 as -8 over 2, because 8 over 2 is the same thing as 4. So we're going to get y equals -3/2 x. 3/2 minus 8/2 is going to be -5/2. That would be your final answer. Okay? So that's back. Those are Algebra 1 topics that we're kind of bringing back, so we need to make sure we still know how to do. All right, so that's going to be all for this video. Next video is going to be all about slopes and x-intercepts and solving and different things like that. So make sure you guys check into that one if you need extra help. All right, bye-bye.